Hi, my name is Saruni. We are Group Cloud Warriors, and we're going to present our solution to the project. So, an introduction to give a bit of a background into our project. Recently, there's been a growing number of users of AI systems, agents, and LLMs. People often use cloud models, but these cloud models usually come with risks and security hazards. So, one of the problems that we're trying to solve is the problem of unsecured LLM inference for Amazon Bedrock agents. And to solve this problem, we tested three different environments where we had a baseline environment with an Amazon Bedrock agent connected to a knowledge base with zero filters. We had another environment with an Amazon Bedrock agent with guardrails only. And we had a third environment where we implemented a multi-layered security system to protect the agent from attacks by using the OWASP top 10 for LLM models. So to give a brief about our architecture, so here we have a user. Now, before the user accesses our system, the request is sent to AWS WAF and Shield, which is going to basically filter out the traffic. And the validated traffic is going to be sent to an API gateway that connects to our agent. Now, before the request is processed by the agent, the process is taken through our Python script, our custom-made Python script, and will be checked for injection, attacks, any types of hallucinations, hypoglycemia, and all of this will be logged, and the logs will be stored in CloudWatch and saved in S3 buckets. Also, an alert will be sent through the Amazon SNS email service to alert the admin of the agent that there has been an attack that has been tried. So here, for example, let's take a path where a malicious user tries to do an indirect translation injection. The script would run an injection check, and if the injection is detected, it will be blocked and the user will be notified. If the input is checked and sanitized, the input goes through to the Bedrock agent. Then the guardrails are checked, this is the third layer of our implementation. The guardrails are checked. The LLM checks the knowledge base before it can give a response, then gives a response. But before the response can be taken out to the user, the response is also validated for hallucination checks. If the response has low confidence, the agent generates another response. So this is different from a human in the loop system. The agent checks itself, whereas our Python script has parts where the agent checks for the confidence of the result and produces results. Once the results are of high confidence, we have an output, which is sent to the user, therefore protecting the system even more. To show you briefly how we implemented the system, we see here Amazon Bedrock. Now, these Bedrock agents are three different agents showing the three different environments that we set. We have the three different Lambda functions connecting to the different agents, which is the base agent, the security agent that we made, and the agent with the guardrails. We also have different systems that we connected through. We connected to the Amazon API gateway, WAF, and other systems that I introduced earlier. Now I'd like to welcome Mahir to talk more about his testing system.
Yes, thank you. Can you see the screen, Saruni, just to be clear?
No, yes, I can see your screen.
All right. Okay. So this is basically the code that we will be submitting as well as part of our submissions through Canvas. So generally, the project has four main parts. The first one is, the most important part is the source. Under this, we have the base agent. We have the Lambda function that is running on AWS. We have the test suite that we will be going through as well, where we really stress test everything that we have implemented and Saruni has talked about. And the knowledge base also Saruni has talked about is basically here. We inject some knowledge base as well that, through queries, we try to search for and ask the AI agent to tell us what's going on. So generally, these are basically the files that we have. The Lambda function is actually one of the most important. So this is the layer 2. And so first we have the input filter function. So there we have two checks. The first is basically regular expression, the regex. This basically catch standard patterns like, when we say, okay, ignore all previous instructions, or someone would say system override. These type of instructions are very much easy to check for any suspicious patterns. So this is the first part of the security check. The second is the typo glycemia, which is the fuzzy match. So it checks if a word is an anagram or a dangerous word with the same first and last letter. So if we have something like ignore, right? I-G-N-ROE, this would be caught as a scrambled version of ignore, which is IGNORE, right? So that's two-step security check generally that we are doing in the system. And next, we have the confidence score. So that's the level 4. So this is part of the hallucination check. It's actually inspired by the self-check GPT. This is one of the other um, projects that we were looking into previously. And so how it works is after the agent answers, we send the same query 2 more times with fresh session IDs, and then we compute the trigram Jaccard similarity between all 3 responses that we get. So the overall logic is if the score is below 0.35, the answers are too inconsistent. So we flag and we retry. If it still fails, we return to a safe fallback, and the HTML that escapes in the end, at the end of the Lambda handler, is what it produces those, at hash 27 and all of these HTML tags that there is. You'll see all of this in the output. So this is generally the Lambda function. We have the knowledge base as well that I showed earlier on. It's basically, we have the S3 bucket and then all of these addresses we have, like the region and then a knowledge base ID, and then we just simply push through. So these are basically the sources. You would actually be able to see all of the test results that we have gotten throughout the time. Generally, we would advise you to just go through the report. But if you're interested in seeing how the test has been evolved over time, and really we have improved on layer by layer, and we tested and tried out, and we made sure that everything is very explainable, and second, everything is very traceable, so that we know the chain of reasoning and thought we had when we were coming up with this idea. So there's that. And then we have the test suite, which is basically all of the commands that we make. So we have XSS test, hallucination test, and legitimate tests. And all of these would return each functions and each results. So there's leaked, refused, failed as well, and passed. So an error. So these are the ones that we have, and this is one of the outputs. So to replicate this, first we need to make sure that everything is set up on AWS, right? Like the Lambda functions, and it can be all of the other functions that are written in the report. After those are done, when we have the Python source codes folder, and then we do testsuite.py, it would basically send all of the injections from the beginning. So the test suite runs 21 tests across 3 configurations. This is the first config that we see, the config base agent. And if we look at test 7, it basically, test 7, 8, and 9, so these 3 were basically leaked. So generally the JSON audit attack on test 8 returned the full system prompt. So basically persona, instructions, and everything. So this is one. So this is base agent. There were no guardrails and no Lambda as well to begin with. And then we have configuration 2 that adds on the guardrails. So 8 of the 9 injections are now refused, which is a good sign of the security generally. But test 7, the French translation attack was actually initiated by Saruni. He came up with this idea of whether a different language could infringe the fact that the security would overpass and they would actually respond. So this was a very interesting find from the team, that the French translation attack still gets through. So the guardrail topic filters, this filter in fact does not catch indirect multilingual framing. So this is where we realize, okay, I think there would be some ways to improve even more, which brings us to configuration 3, which is a full pipeline, the WAF and Lambda and guardrails. And in config 3, you can see that the tests 1, 2, 3, 4, and 8 here that you can see are all blocked under 1.3 seconds. And these actually never reach bedrock at all. So the remaining 4 get safe responses or confidence fallbacks. So there's 0 leaks to begin with. And the trade-off is generally in the summary trade table that is also generated. This is, I think it's a very nice table to have a holistic view of what's happening generally. So the legitimate queries generally take around 19 seconds. As you would be able to see, some of them take 20 seconds. And throughout the full pipeline versus the 2.5 seconds of the base agent. So that's the cost of the self-check GPT sampling loop, which makes 3 bedrock calls per request. So this is generally what we have done on the implementation side. Yeah, so that's all from my side. Saruni, if you have anything to add.
Can you show how to run the program?
Sure. So in terms of the running, it's generally, so if we go here, so all we have to do is, this is a Python. So to begin with, we would need to install the requirements file that we have here. So pip install -r requirements.txt. Once we have everything loaded, we say Python, and we go to the source file, right? The source folder directory, so src, and then we have 4 of them, right? So we go for test suite. When we do the test suite, we press enter, and then it begins the injections. As you can see, one by one, it would put in all of the responses, and then it would come up. The reason why we did not do it on one go is each of these actually takes a lot of time, especially when we go to our implementation of the most secure bedrocks and guardrails and Lambda injections. If you can see, like, each of them takes longer time. So just to save time and have the flow, this is the reason why we did not. But as you can see, these are all of these tests are running, and it would really take some time to complete. So yeah, that's exactly how we run the code and try to replicate what we have done, especially the TAs who are looking into the project and the video. Yeah.
Yeah, thank you.
All right, thank you so much.